exponents have to be equal to each other. So I'd have to solve 6x plus 1 equals 4x minus 1. I can ignore the base, set the exponents equal to each other, and just solve for x. So if I was solving for x, I would subtract 4x on both sides. I'd also get 2x plus 1 equals negative 1. Subtract 1 from both sides. So I have 2x equals negative 2. Divide by 2. I didn't leave enough room. X equals negative 1. Are you with me on that? So if the base is the same, you can set the exponents equal to each other. In number 2, are the bases the same? No. So I need to make them the same. 4 is really 2 to what power? 2 squared, right? So I can leave 2 to the x plus 7 by itself, and then this is 2 squared raised to the x power. Oops. So now I've got 2 to the x plus 7 equals 2 to the 2x power, because I multiply those two exponents together and I get 2x. So now you're at the point where you can set your two exponents equal to each other and solve for x. So if x plus 7 equals 2x, when you subtract x from both sides, don't you just get 7 equals x? What would you get for number 3? What would x have to be to make number 3 true? Negative 3, right? If x is negative 3, then you get e cubed equals e cubed. All right, number 4 is a little bit tricky. What base do these numbers both have in common? A base of 2. So how do I represent 1/2 using a base of 2? It'd be 2 to what power is 1/2? So 2 to the negative first power raised to the x power. So this is really the number 1/2 raised to the x power. 4 we already said was 2 squared. And then we've got the x plus 4 power. So I'm going to set these exponents equal to each other. So this exponent is really negative 1x, and this exponent is really 2x plus 8 when I distribute, right? So see how they both have a base of 2? So I can set negative 1x equal to 2x plus 8 and solve for x. So could you take that algebraically, the one last step, and solve for x and see what you get? I'll give you a minute. So solve for x on that. So you would subtract the 2x to the other side, right? So that gives you negative 3x on the left equals positive 8. So your last step would be dividing by negative 3. So you'd have negative 8/3 as your final answer. So it might not come out beautiful, but it's mathematically correct. And you could check it by plugging it into a calculator if you wanted to, but. So that's the one-to-one property. You force the bases to be the same so the exponents can be the same. So on 5 and 6, there's also a one-to-one property for logarithms. If the bases of the logs are the same, then guess what? The stuff inside the logs also has to be the same. So in this case, x would have to be just 7 to make that statement true. And on number 6, if you put that natural log of 3 on the other side, you would have the natural log of x equals the natural log of 3. So doesn't x also have to be 3 for this one? Same reason why as over here. Same base, so x is 7. Same base, so x is 3. What base does the natural log have? E. So even though it's not written there, the base is e and the base is e on both sides. So the stuff inside you can set equal to each other. So all of those, 1 through 6, I just did without a calculator. So now we're going to start seeing problems that I cannot make the bases the same. So 2 to the x equals 10. 10 is not in the power family for 2. I know that 2 cubed is 8, and 2 to the 4th is 16. So my answer is going to be 3 point something, but how do I get exactly what x is? So there's two ways that you can think about this. You pick the way that you like best. The way I was taught is to take the log of both sides of the equation, because whatever you do to one side, you're allowed to do to the other side. So take the log of 2 to the x and take the log of 10. Once you take the log of both sides of the equation, you've got that power rule. So this coefficient of x can actually come down front as a coefficient. X times the log of 2 equals the log of 10. And the log of 2 is just a number, so you can divide both sides of the equation by the log of 2, and that's going to give you your answer on a calculator. So you need a calculator to be trying these. So grab one, either if it's not under your seat, then grab one from the back wall, because I sanitized them last week. You're going to do the log of 10 on your calculator, close parentheses, and you're going to divide by the log of 2 on your calculator and get 3.32. Remember I said it was going to be a decimal of 3.32, for example? So that should make sense. 2 to the 3.32 power will give me 10. So I want to show you something that could be a shortcut for some of you. So this is taking the log of both sides, bringing x down as a power, dividing by the log of 2 on both sides. You could also just change form into log form. If this is the exponential function, isn't the log base 2 of 10 equal to x, the log version of that function? So can't you just type the log base 2 of 10 into your calculator? And that's under the math log base key. So the log base 2 of 10 gives me that same answer, 3.32. So you can either change form into log form or take the log of both sides and then basically divide by that log. So if you look at example 2, I've got 2 on the left and 3 on the right. Those never have the same power family. So if I just want to change form on this one, I would say that the log base 2 of 3 equals x plus 1. See how 2 raised to the x plus 1 power equals 3? So if you like just changing form into log form, to me that's a little bit easier if you understand how to go between the two forms. But if you don't, you would take the log of both sides and do the division. So you're going to evaluate the log base 2 of 3 on your calculator, and then at the end, you'd have to subtract 1 from your final answer. So this one I did by changing forms. The next one I'll do by taking the log of both sides just to show you. So if you do the log base 2 of 3, go to the math button, change the base. The log base 2 of 3 is 1.58, and we're subtracting 1. So 0.58 is the answer. And if you wanted to do it by taking the log of both sides, you would have gotten the same answer. So the log of 2 to the x plus 1 equals the log of 3. The x plus 1 comes down front as a coefficient. You divide by the log of 2 on both sides. So you have x plus 1 equals the log of 3 divided by the log of 2. And then at the end, you subtract 1. So it's the same process either way. All right, let's do number 3 maybe together, and then maybe you try 4, 5, 6. On number 3, you have to get e to the x by itself before you start solving anything. So e to the x power equals 55, because I subtract 5 from both sides of the equation. So to me, a shortcut, instead of taking the log of both sides, it'll be special if you take the natural log of both sides, because if the base is already e, something special happens. So if you take the natural log of both sides of the equation, you'd have the natural log of e to the x equals the natural log of 55. Your next step is that your x comes down front. Now you just have the natural log of e. What is the natural log of e? So the base is e. If the base matches the number inside, isn't that just equal to 1? Right? The log base 3 of 3 is 1. The log base 9 of 9 is 1. E to the first power is e. So that's just 1. So it's like a little shortcut because all you have to do is evaluate the natural log of 55 and you've got your answer. So if you ever have a base of e, take the natural log of both sides instead of taking the log of both sides. And the natural log button is right below the log button on your calculator. So the natural log of 55 is 4.01. So that's the answer to number 3, 4.01. So try 4, 5, and 6. When you get to number 4, what's going to be your first step before you do anything? On number 4, what's going to be your first step? Divide by 4 on both sides. So before you start the problem for number 4, divide by 4 on both sides of the equation. See if you can do 4, 5, and 6. So I'm just putting up number 4, but I think we pretty much got there. We're going to end up taking the natural log of 5/4 on our calculator. And then at the end, because we had 2x over here, we'll have to divide our answer by 2. So the natural log of 5/4 divided by 2 comes out to 0.11. So here's how it looked on my calculator. Natural log of 5/4, I closed parentheses, hit enter, and then divided that answer by 2. So 0.11 should be the answer for number 4. And if you're still trying 5 and 6 for a minute, that's great. I'd rather you try it first because we're going to keep using this as practice. This is not on tonight's homework. Tonight's homework only goes through properties of logs. Yeah, I took the log this time because the base was 4, so I didn't have to take the natural log, so I just used the regular log of both sides. This x plus 7 can now scoot down front as a coefficient, so I've got x plus 7 log of 4 equals the log of 21. The log of 4 is a number, so I'm going to take both sides and divide by the log of 4. So this is just a number. The log of 21 divided by the log of 4 is a number on my calculator. Hit enter. And then the end, if this was x plus 7, your last step is going to have to be to subtract 7 from whatever you got. I got negative 4.8. So there's my log of 21 divided by the log of 4, and then I subtracted 7 to get that negative 4.8. So when I do logs, I don't write down all my steps in between because it's all decimals. The log of 21 is a number. Why write down that the log of 21 is 1.322? Like, how does that help you? So I just leave it as the log of 21 on my paper. That's a number. The log of 4 is a number. Subtract 7, negative 4.8. All right, so I think I'm going to power through. I'd like to do the back side, and then we will take a walk. But I think I'd rather do the back side while we're in the flow, and then there's only, 8 questions on this side. The challenge I'll leave off for now. So if you start in log form, I gave you this example over here of exponentiating, but I'd kind of like you to cross that out because I think that method is a little bit confusing. So all I do is instead of doing this method at the top, all I do is switch to exponential form. I had showed you that as a strategy on the front page, switching to log form. To me, it's easier on the front page to take the log of both sides. I think switching to exponential form is the way to go for the back page. So let me show you what I mean. On example 1, your first step is to get that log expression by itself. So this log of x, or natural log of x by itself. So you would start by subtracting 5 on both sides. So you'd have 2 natural log of x's equals -1 as your first step. What would be my next step of getting that log by itself? Divide by 2. So I've got the natural log of x equals -1/2. So what do I mean by switching to exponential form? Rewrite this as an exponential expression. What's the base? E, right? So if the base is e, the exponential expression is e to the -1/2 power gives you x. E to the -1/2 power gives you x. So you're going to evaluate e to the -1/2 power on your calculator, and it'll give you your answer. So does everyone know where the E button is on their calculator? Second, you can either use the one that's over the divided by symbol or the one that's over the natural log symbol. The one over the natural log is e to a power, so that one's maybe easier. To the -0.5, 0.61. So e to the -1/2 power is 0.61. So I didn't have to take the log of both sides or anything crazy. Get the log by itself and switch to exponential form. So I actually think the back page is easier than the front page. Solving logs is actually easier than solving exponential, I think. So let's do another one together, and then I'm going to have you try some. What would I do to get this log expression by itself? What would be my first step? Divide by 2 again. So I've got the log base 6 of 3x is inside the log equals 2. Who can write for me my exponential expression? The base is 6 squared equals 3x. 6 squared equals 3x. If 36 is equal to 3x, what does x have to equal? What? 12. So I could do that one without a calculator. Do you think you can try those, or do you want to do a couple more together? It's weird. You want to do 3 and 4 together then, maybe? Let's do 3 and 4 together. Number 3, you want to get this log function by itself. So if you want to get the log function by itself, what things do you have to strip away to get to the other side? First, you'd have to add 5 to both sides. So this step is just algebra, like your old friend algebra. So I've got 2 of those logs equal to 7. So one of those logs has to be equal to how much? Perfect. Divide by 2 on both sides, right? So what is my exponential expression? The base is 3 to the 3.5 power equals x. So it gets you more comfortable with switching from log to exponential form. So what is 3 to the 3.5 power, someone? Perfect. How to jump in, Garrison. Nice job. 46.77. Right, you're right with us. Nice. All right, one more together, and then the challenge I'm leaving till next time. You're going to try 5, 7, 8, and then you've earned your walk. All right, so number 4. I need to get that log by itself. So what do I need to strip off to the other side first? First, I need to subtract 1 to the other side. So 3 natural log of x equals 4. Now I'm going to divide by 3 on both sides. So now I have the natural log of x equals 4/3. You need a base in order to switch forms. So what's the base that's missing here? E. So E raised to the 4/3 power will give me the x that's inside the log. E to the 4/3 power equals x. So take E on your calculator and raise it to the 4/3 power. And tell me what you get. Yep, 3.79. All right, see if you can get through 5, 7, 7 comes out as a really big number. Can you change number 7 to just equals 4 for me instead of 40 so that we don't blow up and get a $1 million answer here? So 5, 7, and 8. If you could try 5, 7, and 8, change number 7 to a 4. I keep meaning the base is E because it's a log, a natural log. Just like in number 5, the base is 10. So if you ever don't have a base, if it's the word log, you make a base of 10. If it's the word natural log, ln, it's a base of E. I kind of wish it wasn't a ln. Some people think that's like a number 1. I wish they had thought of a different notation, but. So that's solving logs. If you're still a little shaky on it, tonight's homework does not ask you to solve logs using this method. So anything on the homework tonight actually is